This video is going to be the first part of chapter 10, looking at section 10.3. So a little bit of background about atoms and electrons. There was a scientist in the 1800s called Niels Bohr who actually had an idea that said that while we have our nucleus holding our protons and neutrons, we had these sort of like train tracks that were possible places where we could find our electrons. And that electrons would then move around in circles on those train tracks. And while he was close, he was a little off. And so what our explanation for this are going to be called orbitals. And so orbitals are going to have our general region of space where we're most likely to find an electron. And so you can see here, the darker the region, the higher the probability of where an electron might be. Why it's important in chemistry to keep track of these is that certain amounts of electrons can fit in each orbital, and since we know how important electrons are to reactivity and to bonding, we need to know how many are in each. So we're going to focus on having 4 energy levels of orbitals. Okay, so you'll need to know exactly how many electrons are found in each energy level, and we'll get to the numbers in a second. But just to show you a little bit of information about them, we're going to go through here. So in the first quantum energy level, we're going to call this n equals 1. It's only going to contain one orbital, and you can actually see our plane here of where we might find an electron. So this is, again, 90% probability of where the electron might be located. In quantum energy level 2, the 2s are actually longer. You can see on these axes, we also have our x, y, and z axes giving us 3-dimensionality. And so in this case, we have 2 electrons fitting in each one. So it gives us a total of 6 extra electrons. So this means that on our second energy level, we have our s orbitals and we have our p orbitals. So we have a total of 8 in the second energy level. In energy level 3, we have s, p, and d orbitals. And d, again, looking at how they are structured, again, looking in 3-dimensional. We have 5 different types of orbitals, so that's going to give us another 10 electrons, as 2 can occupy each orbital. So this chart actually shows you how many spots we might be able to find electrons. And so, for example, in quantum energy level 1, we have 1 orbital, so that means we're going to have 2 electrons. In energy level 2, we have 4 orbitals, so we're 1s and 3 p's, so we're going to have 8. 3, we're going to have 9, so we're going to have 18. And those are the numbers I want you to know. So how many electrons can fit on level 1? 2. How many can fit on level 2? 8. And how many can fit on 3? 18. That's it for this section. So what is the maximum number of electrons that can occupy the n equals 3 sublevel? This, of course, would be 18. Okay, so n has 3 types of orbitals, an s, p, and a d. Each one of these can hold 2 electrons, so we have 18 total. That's it for this section.